Class 9, are you there? Namaste, good afternoon.
Good afternoon, sir.
Welcome everyone. So, did you take that previous class? Yeah, Shubham, namaste, how are you? Fine, Isha,
I'm fine, sir.
Sansu. Yes, okay. May I request the students of class 9 to switch on the videos? Yes, Sudha. Yes. Okay, soon we will start the class. Okay. So, let me not take the time. Okay. Let's begin to read today's class. You know the lesson class 9? Which lessons are we going through? Chapter? Which chapter are we going through?
Force and motion.
Yeah, very good. Yes, that is unit 2, okay, force and motion. And today we are going to read equations of motion. Before that, let's have few minutes, okay, recap. So recap of the previous topic that we discussed, velocity time graph. They have got one problem, the same problem that we discussed last time, similar. Okay. Okay, class 9. Now be ready for the class. Class 9, on your screen, you can see, okay, the slide I have shared. This is the question. The question is, study the given graph and answer the following questions. So observe the graph, okay, on your screens very carefully. The graph is between velocity and time, by which we can analyze the oscillation of body, okay. Oscillations of a body can be calculated, okay, by the graph between velocity and time. And let me tell you, class 9, in the mean, we can calculate acceleration of a body either by analytical method or graphical method. Analytical method means using formula, equation. Okay, just like A equal B minus U upon T. So by using that expressions, if we get acceleration of a body, means we are following analytical method. Now, when we are given the graph and by, okay, that looking the data of velocity and time, when we find the acceleration of respective lines, so this method is called graphical method. Okay, and in graphical method, okay, in graphical way, we find acceleration by calculating the slope of line, because slope of line is the acceleration of a body. Okay, so please observe the graph carefully. You can see the straight line, that OA, okay, AB and BC, OA, AB and BC. And the questions are as follows. The first question is there. Name the type of motion, and here motion means acceleration, represented by OA, AB, and BC. The question is asking you to answer what type of acceleration, okay, can be calculated, can be analyzed by the line OA, AB, and BC. Okay, that means when body is moving from O to A at the time, what type of oscillations does a body acquire? The answer of this question, first question, okay, let me show the slide. So where you can see the answer. Yeah, the whole slide is, okay, the answer of first question only. The first question is, name the type of the motion represented by OA, AB, and BC. First for OA. Now how to give answer? See, OA is the straight line, and straight line means obviously which type of acceleration? Uniform. Okay, uniform acceleration. Okay, so OA is the straight line. Okay, that is a graph of velocity and time. So it represents uniform acceleration. And whenever you use only word acceleration, class 9, that is obviously positive acceleration. So OA represents, okay, uniform acceleration, okay, which is positive as well. Clear? Now the second line AB. See here, if you see the line AB, you can easily find that is parallel to, okay, that is x-axis, and on x-axis we have the data of time, so that is time axis. And whenever the line is found parallel to x-axis, okay, its slope is zero, and its slope is zero means what? That means its oscillation zero. Okay, so the motion that is shown by the line AB is what? It has zero oscillation means its velocity is uniform. Got it? The line AB represents the uniform velocity, that is zero acceleration. And finally the third line BC. Okay, you can see though the line is sloping downward, okay, that is also a straight line. So in these questions you do not find any curved line, okay. And let me tell you, class 9, you will not be asked to find the oscillation of curved line. Remember, straight line, okay, always you will be asked. Here in BC, that 2 is also a straight line. Obviously that also shows uniform oscillation, but you can see the slope is negative, going downward. Okay, that shows the decrease in velocity. So the straight line BC represents the uniform, okay, negative acceleration. That means retardation. That is also uniform but negative. So uniform retardation. AB, okay, uniform acceleration. Sorry, OA, AB zero acceleration, and BC, that is negative accelerations, which is uniform too. Okay, OA uniform positive accelerations, AB uniform velocity zero acceleration, and BC, that is negative. Now let me go to the second question. What is the second question there? Calculate the acceleration. So if you see the second question in the picture, you can find calculate the acceleration. And here acceleration means positive acceleration. Okay, you have to understand there. That means second question is asking you to find the slope of OA, even not AB, because AB has zero acceleration. That means AB already has zero oscillation means you don't need to find that, okay? Oscillation means that is positive acceleration. So we are going to calculate the oscillations of OA. See here, second answer is OA represents oscillations. Once you are clear, then you can find the oscillation by this way. See, isn't it? OA oscillation means that is slope of OA, and slope of OA, it is given by tan integral P by B. And if you see the picture or figure over there, you can see triangle AOD. In triangle OAD, if that angle AOD is theta, obviously OD will be base and AD will be perpendicular, right? And for the line OA, okay, and that ratio will be, that is AD by OD. So slope of OA will be given by AD upon OD. And AD is how much? You can see, okay, on y-axis that AD is 15, right? And OD is how much? You can see on x-axis, that is 5. So 15 upon 5 is 3 meter per second square. See, without using formula, okay, by graphical method, with the help of slope, we can directly find acceleration, because accelerations is the slope of line, okay, if the graph is between velocity and time. Got it? Okay, so here that acceleration is OA, and how much is that is 3 meter per second square. Please understand this properly, please. This is very important part of this lesson. Now next is third question. You are asked to find the retardation, and retardation means negative acceleration. So among these three lines, which one shows retardation? Okay, we already discussed in number 1, that is BC. So BC represents retardation. Okay, and to find retardation, it is necessary to find the slope of that BC. And since BC is at obtuse and its slope is negative. Okay, if you see the slide, I have not written that minus BE upon EC. Okay, because already retardation means itself negative. Retardation is minus A. Okay, if you have written simply this oscillation here, that means you must keep minus B upon EC. Already at the left hand side of the equation, you have written retardation. So that shows, okay, the slope is negative. Retardation means negative. So already there is minus, okay, that is minus A. And here, B upon EC, how much is B there? See there, B here. Seen there? Okay, perpendicular to the, that is, x-axis B. So it is also 15. Okay, and if you see the graph there, EC, then how much there? Okay, 15 minus 10. From O to C is 15, and from O to E is 10. And remaining EC will be 15 minus 10, that is whole part exam. And 15 minus 10 is 5 there. So it is also 3 meter per second square. Okay, it is negative 3 meter per second square. Since we have already written as a retardation, so okay, that is written as positive. Got it? Okay. Now I'll come back to you for a few seconds, then we'll start today's topic. Class 9, did you understand how to find the acceleration when you are given the graph between velocity and time? बुझ्यो तिमीले क्लास 9? सन्सु बुझ्यो? सुदाले बुझेको बुझेन?
Yes, sir. Yes, sir.
सुदाले बुझेको बुझेन? Sudha, can you hear me or
Yes, sir.
not? Oh, yes. What's about
Yes, sir.
Anushka? What's about Anushka?
I'm understanding.
Yeah. Yes, I only Sansu, Anushka, Sudha. Okay, Subham, Vivek, Subham, that is Arya and Nisha, and well, others. Yeah, Karya, I know, but others. Yeah, Jendra, thank you. Please do not hesitate, class 9. Actually, why we do not get problem if we just show your face to others. Okay, let me not kill the time. Now today's topic, class 9, I request you to be ready with copy and pen, because in today's class, okay, I'll talk less because you are going to write more, because our topic is equations of motion. Okay, you must know how to derive, okay, the equations, so that for that you have to practice. You know, because you have read in the previous class also, that B equal U plus AT, yeah, S equal UT plus half AT square. So I'll show the slide and you'll copy, okay? You'll note in your, sorry, class 9, just wait, okay? Okay, yes, class 9. In short, let's know about equations of motions. So equation of motions are the relation between or among the quantities like velocity, displacement, acceleration, and time. So you have some symbols, Subhat, yes, Subhat for S for displacement, U for initial velocity, B for final velocity, A for accelerations, and finally T for time taken, okay? And these equations, okay, describe the motions of body with the uniform oscillations. And we use these equations to calculate the quantities when other quantities are given. Now let's go to derive 3 equations of motion. The first equation of motion is B equal U plus AT. Please start writing on a copy, please, class 9. So the question is, okay, prove, P-R-O-V, prove B equal U plus AT. So when you are asked to prove the equation B equal U plus AT, which is equation first of motion, for that, we have to start with the language that consider a body moving with velocity. Which velocity? Initial velocity. Okay, consider a body moving with initial velocity U accelerates, okay, at uniform rate, accelerates at uniform rate A, and then you have let B, small b, be the final velocity. This language is compulsory, okay? You have to consider the meaning of symbols, okay? The symbols denotation you have to consider. and let small b be the final velocity after time t. That time is small t, and s, small s, okay, with the displacement. So you have all the symbols, so which represent different quantities. U for initial velocity, A for acceleration, B for final velocity, T for time, and S for displacement. Okay, and how to start? We know that this is by the definition of acceleration last night. Okay, the mathematical definition of acceleration is equal to final velocity minus initial velocity upon time taken. Please go on writing. Okay, so I need this. Okay, in a copy, please. Acceleration equal final velocity minus initial velocity upon time taken. And where acceleration is denoted by small a, final velocity is small b minus initial velocity is small u, and whole upon small t. Okay, now cross multiply a into t, at, and changing the sides. Okay, you find b minus u equal at, and at last you have b equal u plus at, and this is the, okay, first equation of motion. This is like revision for you, but remember, okay, to find b equal u plus at or b minus u equal at, how to start? We start by writing the language for considering the symbols or quantities. Then the initiation is what? Definition of acceleration. Okay, definition of acceleration is changing velocity upon time. So you got this. And let's go to the second equation of motion. So did you finish class 9? Yes. Now this is second equation of motions. So if you are asked to prove S equal ut plus half at square, this is another
Sir,
equation of
once,
motion.
so the equation, first one.
First one? Okay, okay. Okay, yes, please. Yes, here you have. So if you get confused in any step, okay, please you can respond.
Okay,
The
sir.
important part is you have to know the first step. Okay, that is just like for equation first. So we have the first step is a definition of oscillation. That is oscillation equal final velocity minus initial velocity upon time. If you know this, then you can easily find the equation of motion first. Now, yes, please. Now class 9, please be ready for the second equation of motion. So which we are going to prove s equal ut plus half at square. I think the letters are so small. And if you are asked to prove s equal ut plus half at square plus 9, please do not start directly from here. Okay, you have to consider by writing a language, the same language you can. Just like let a body. Okay, let us consider a body moving from, rest with the initial velocity u, and that accelerates at the rate of a, then, and the b be the final velocity after time t, and small s be the displacement. After writing that language only, then you can start writing this step. So which you can see at the top of the screen. Second equation of motions. Okay, now how to start for proving the second equation class 9, s equal ut plus half at square. Average velocity. So how many types of velocity now we know? Okay, we are talking about two velocity, that is initial velocity and final velocity. So we have two velocities as initial and final. And how to find average? Obviously, initial velocity plus final velocity upon 2. Okay, let's start from the definition of average velocity. So to prove s equal ut plus half it square, so let's start from the definition of average velocity. Okay, by the definition of average velocity equal initial velocity plus final velocity whole upon 2, because there are only two velocities. Okay, and average velocity can be denoted by VAV. Okay, VAV, that is for average velocity, or simply you can write V equal initial velocity already we considered, that is U, and final velocity is small b, so U plus B whole upon. Now, so if we go, so in another way for finding the average velocity, So we can say displacement travel, okay, or distance travel in a straight line upon time. Okay, that means for the same average velocity, so we can have another relation. Okay, that is average velocity equal displacement upon time. So here you can say distance travel in place of displacement. So if there is average velocity equal displacement upon time, then you can get displacement equal average velocity into time. Yes. See, so displacement travel, distance travel is small as equal, and from above, see the expression for average velocity. Okay, we have u plus b whole upon 2 and into small t, that is time. So which we have equation first. So did you understand? Like at first we have the mathematical relations of average velocity as u plus b upon 2, and in another way we again write the average velocity, that is displacement upon time. Means displacement is equal average velocity upon time. And we substitute the value from above. In place of average velocity, we have written u plus b whole upon 2 and into t, this time t. Now let's go to the first equation of motions, which we have already got. V equal u plus at. Okay, this we need later on. Now by using this fall, that is equation 1, s equal u plus b whole upon 2, okay, into t. This one. By using this equation and putting this value, means b equal u plus at. So if you substitute that u plus at, this one, u plus at in place of small t, then you will get like this, u plus u plus 80. Okay, u plus 80 whole upon 2 into t. We are using this equation, okay, that equation 1. And in equation 1, okay, where we have small b, then we substitute this value, b equal u plus 80. In place of small b, we have put u plus 80. This is later on, okay, or s equal u plus u is equal to 2u and plus 80. Okay, addition of u and u, 2u plus 80 as it is, whole upon 2 into t. Okay, same. And next step, that is or here for this one, this step. So we have multiplied, okay, this expression by t, and t multiply whole. Okay, t multiplies whole means 2u into t. It will be 2ut. Okay, 2ut plus a2 80 into t, 80 into t, 80 square, and whole upon 2. Now when we have the fraction that has only one denominator, so we can break it. Then there will be like this. Okay, s equal 2ut upon 2, right? Plus, yes, 80 square upon 2. This is not shown in this step. We are separated. So 2ut upon 2 plus 80 square upon 2. So this 2 cancel, and there will be only ut plus and 1 upon 2, 80 square. Finally, we got this equation, equation second. So here we have started from the, okay, mathematical relation of average velocity, u plus b whole upon 2. Then again we have used, okay, another expression for average velocity, displacement upon time. That means displacement equal average velocity into time, and we have put the value of average velocity as u plus b whole upon 2. Okay, then here, so in u plus b whole upon 2, we have substitute the value of b as u plus 80. Okay, it will become that u plus 80 upon 2 into t, right? And this is calculations. So this way we have got, okay, that is second equations of motion. So if you are done, now let's go to third one. Third equation is this one. This is v square is equal to u square plus 2as. So we are going to derive the third equation of motion. v square
to.
is equal to u square plus 2as. And to derive this equation also, class 9, please you have to start with the language. You have to consider a body moving with initial velocity u, okay, with oscillation a, and it gains final velocity v after time t, so which covers displacement small s. And after writing that language, then you can start from here. Okay, equation of first of motions, or you can say first equation of motions. What expression we have, class 9? V equal u plus at, right? And v is equal to u plus at means it is also v minus u equal at. Yes. Now if you write in this way, v, okay, minus u equal at, this is v equal u plus at, only written in this form. The next we have, already we came to know in equation second of motion, or second equation of motions, VAB, that is average velocity, which is u plus b, okay, whole upon 2. Initial velocity plus final velocity upon 2. So rearranging, then you will have what? 2 average velocity equal u plus b, right? That means finally you can get v plus u equal to VAB, is 2 average velocity. So from equation first, that is first equation of motion, we have v minus u equal at, and from the average velocity, so you have what? V plus u equal to VAB. Okay. Now here you have equation first. Okay, this is this one equation first. Okay, in this case, and this is equation second. So let's multiply both equations. So you have v minus u, okay, at the left hand side in equation first, and you have v plus u at the left hand side in equation second, and b minus u, b plus u. It is just like a minus b, a plus b. Okay, then product will be v square minus u square. Okay, multiplying b minus u, v plus u, v square minus u square. And at right hand side you have at in equation first, and 2VAB in equation second, and it will be 2AT from here AT, and from here 2VAB. You got like this. Okay. Yes, finally by multiplying equation first and second, so you got the expression like this: v square minus u square equal to 2AT. So v square minus u square in next step as it is. Okay. And here in place of, see here in place of t into VAB, so you can replace s for displacement. Average velocity, okay, equal displacement upon time. That means displacement equal average velocity into time, and you have here time into average velocity means that is displacement. Okay, here time into VAB means this is displacement. Okay, so we have here, so you got v square minus u square equal to as, which is third equation of motion. This can be also written as v square equal u square plus 2as. So if you write in this form, then you can find final velocity. So when the question has given you initial velocity, oscillations, and displacement, so it doesn't have time. This, okay, relation doesn't have time. Ramro Babu, Ramro. Okay, now this is class of for you, class 10. You can copy these questions. Okay, do as homework, please. A car starts to move from rest and attains an acceleration of 6 meters per second square. After 12 seconds, calculate the distance covered by the car. Try this yourself. Please, you can take the screenshot. Okay. क्लास 9 यो तीनटा इक्वेसन हामीले जुन डिराइभ गर्यौ नि, बुझ्यौ तिमीहरूले? ल त्यसलाई प्र्याक्टिस गर है, 2-3 चोटी प्र्याक्टिस गर। तिमीले नहेरिकन चाहिँ गर्न सक्ने
Can you show code?
है, जस्तै 2 v equal u plus 80 questions.
Yes sir, one question.
Question class 9. The same questions I'll keep in the Google Classroom, okay? as homework, please. Today this much class 9. Thank you so much. Bye bye. Thank you.
Bye, sir.